Hello, everyone. So I want to start by talking about Consul. The room is pink for Consul. So it's been a really big year for Consul. Last year at HashiCorp, we announced Consul 1.0. Consul has been in use by thousands of companies at very high scale for many years. And so last year, we were super excited to announce 1.0. And this year, we've been really focused on improving those existing features of Consul, but we also, earlier this year, introduced a brand new feature into Consul for secure service connectivity called Connect. And I want to start by taking a step back to talk about the original problem that we built Consul to solve, and by doing this, help sort of explain and paint the picture for why we're building these new functionalities directly into Consul, and what the future also holds for Consul. And so the original problem that we really built Consul to solve was the new challenges introduced by breaking down monoliths into discrete services. And so historically, we started with a monolith. And with monoliths, when one subsystem wants to talk to another subsystem, such as A to B here, it was pretty easy. It was an in-memory function call. One class calls an exported function of another class. All the data is in process. The network's not involved at all. It's fairly straightforward. And when that monolith needs to talk to one of its upstream dependencies, like a database, then that's usually configured with a static IP. In the monolith sort of view of the world, there's not many upstream dependencies. Maybe there's a database, maybe there's a cache, but there's not many things. And so we could just assign static IPs, hard code them into the configuration files, and just connect directly. And then when we want to control who has access to this thing, we put a load balancer in front of it, and we scale horizontally by adding more monoliths, or we scale the backend tier similarly. And then to protect all this from a security perspective, generally you would break this into a few discrete zones. You would have the demilitarized zone in the front, the Wild West, where everyone's trying to hurt you. You'd protect that with a firewall, allow application users into your application, and then you would protect very sensitive data, the actual data lake, with another firewall into the back, so that only applications access data, and they're not behind the load balancer allowing user access. A pretty straightforward and common approach. So that's all well and good. What changed when we started splitting monoliths into microservices? So we started by taking this and realizing we could break this up into discrete network-connected services. The first question is, why would we even want to do this? Well, breaking it up has a number of benefits. It lowers the surface area of each individual sort of application that we're deploying. So it's easier to reason about what features we should add, how do we test it, how do we test it across the board from unit testing and integration testing. We could deploy separately from the other subsystems. And also, more downstream services can consume the same shared upstream service. So if you had 5 applications before that all needed subsystem B, they don't need to compile in a copy of subsystem B into each one. They could all network connect back to one. So there's a lot of benefits here. There's more. But there's no real free lunch here. By breaking down these services and getting more agility in what we do, we've also made a trade-off for new operational challenges. And the first challenge we really run into is that of discoverability. Before, when subsystem A needed to talk to subsystem B, the service discovery tool that handled this for us was our compiler and our linker. They would discover the right memory address to jump to, and you would just jump there and execute code. Now, these are network-connected services. The compiler and linker cannot be used for service discovery, and we have a challenge of how do we find how to talk from A to B. That's problem number 1. Problem number 2 is configuration. When you have one monolith, usually it's fairly easy to configure this thing. That sort of era of application is also heavily correlated with not very many replicas, large servers and not very many replicas. And so you would just put a giant configuration file that configured all the various subsystems of your application right next to it. Maybe this is a giant XML properties file or whatever it is. It's not hard to orchestrate. There's not very many servers, and you just put it there. Now you have many more services. And in this basic example of 4, it's not hard to really comprehend, but realistically you're aiming for hundreds or thousands of services. And now there's a real challenge that's non-trivial for how do we distribute configuration, how do we try to make that configuration almost atomic in its shift, so we're not waiting an hour where one service is configured with version 1 and one is configured with version 2, and how do we actually get visibility in what that consistent configuration should be? there's more questions that arise here, but the general category and problem is that of configuration. And the last challenge is this security challenge, and the one that I'll dive into a little bit more. So in the monolith world, we solve sort of security by breaking up our zones into 3 separate zones separated by firewalls. And the way we do this, the sort of category of solution that we use here is segmentation. And so when we talk about network segmentation, it's really the concept of breaking down a network into a number of subnetworks and controlling the access between them. And the issue with this is it's a fairly coarse-grained approach that has absolutely no idea of the applications running on top of it. So you're saying segment A could talk to segment B or vice versa, and if you deploy the application into the wrong segment, then you've inherently sort of broken the functionality of that application because the security is defined at a different layer. But when you don't have that many applications and you have a fairly flat network, this is an easy approach to do, and it solves the problem by separating the security problem from the deployment problem from the developer problem. It's sort of a traditional, historic, sort of siloed approach to breaking down problems. And it works when it's small. The challenge with microservices and when you start breaking things down is the access patterns aren't as clear. You don't have a clear external to internal, internal to database sort of data pipeline happening in your infrastructure anymore. Now the arrows are going a little bit everywhere. So in this example, we have A talking to B and C. We have C and D talking bidirectionally. We have B talking to D. And nothing else should be able to talk to each other. And if you try to imagine, how do I solve this with firewalls? You might be able to see a solution, but you're already sort of requiring here at a minimum of sort of 4, 5, 6 firewalls between these various services and the complexity of configuring these. And people try to do this. Very commonly, they try to do this. And the real challenge is as you scale this up. Because the reality of adopting microservices is not that you're breaking down a monolith into 4 services. Maybe that's the initial step. The reason people adopt microservices is the expectation that one day you're going to have dozens or hundreds or thousands of services. And it's really going to look like this. And so now, when you look at these connections going around, try to imagine, how do you configure firewalls? Whose job is that? What effect does that have on your deployment speeds? And you start to realize the challenge. The other thing we've realized is that these companies breaking down into microservices very often aren't single cloud. They're on multiple clouds and multiple platforms. So you'll have some things on cloud, you'll have some things in a platform like Kubernetes, and you'll have some things on-prem, and they're not silos. They want to talk to each other. The database might be on-prem that a service in cloud needs to talk to, and how does it get there? And how do you actually do security between these 2 totally separated networks? And so ideally what we'd like to do is create these pairwise sort of rules that service A could talk to B, service C and D could talk bidirectionally, and then create the other set of pairwise rules around A could talk to C and B could talk to D. We want to be able to make these as our segmentation rules for security. And so these are the 3 problems that we see when you're breaking down a monolith into microservices. And we consider them the fundamental problems of really adopting microservices. There's more sort of challenges ahead, but unless you have answers to these, it's hard to really get there. And we combine these categories into what we believe a service mesh must solve in order to provide this base functionality. And for many years, Consul has solved the discovery and configuration problem. Since Consul 0.1, we've supported DNS for service discovery, a nice lowest common denominator approach that any application can integrate with very, very easily to find anything else. Just make the right DNS call, you get an IP address, and you connect right to it. For configuration, we've had a KV store in Consul so that there's a centralized place that supports blocking queries for immediate updates, a central UI so you can see what all the configuration is across your services, and that's in the KV and been there since 0.1. The segmentation problem is one that historically we've had our users look elsewhere. You've had to find other tooling to solve this problem. And a lot of our users were solving this by tying Consul very closely to systems like Proxy or other sort of firewall type layers in front of their services. But we heard time and time again from our users and customers that Consul was just so close to solving this for them, and they really wanted to see the solution. So for the past couple years, we've been sort of planning how to make this a reality, and we talked to some users and customers last year as well about previewing what we were planning on doing. And then earlier this year, at Hashi Days Amsterdam, we announced Consul Connect. And this is built directly into Consul to solve this problem. And this is also why it's not a separate tool and is built directly into Consul, because we can't solve the segmentation problem without also knowing where our services are and what their configuration is. And so naturally, if we built this separately, we would have had to build a plugin interface. We would have integrated very closely with Consul anyways. And by doing it all in one, we've dramatically simplified the deployment and made Connect a much more adoptable, practical tool. And so that was Connect. It's a feature for secure service-to-service communication using automatic TLS encryption and identity-based authorization, and it works everywhere. And I'm just going to really quickly go over what Connect is in more detail rather than the problem. So Connect is comprised of 3 major features. It's a service access graph, it's a mutual TLS and CA, and it has a pluggable data plane. The service access graph is what defines who could actually communicate to each other. We use something called intentions to define what services can or cannot communicate to each other. These are defined using the service names and are completely separate from the hosts that they're on. So you could deploy these services anywhere. You don't need firewalls. You don't need to do network segmentation because the security is handled at the service name layer and not the IP layer. Another benefit of this is it's scale independent. So if you imagine you have a web server, let's say 10 copies of a web server and 3 instances of a database, and they're running on separate hosts, the firewall rules for that are either on one side coarse-grained, where you're saying this block of IP addresses that might include IPs that aren't running the application can communicate. It's sort of like what Armand said earlier. It's sort of the simple policy side. Or you have the highly complex, we're going to create a pairwise, this IP could talk to this IP for every single instance, and you end up with sort of a multiplicative explosion of firewall rules. Either way is really complicated and really expensive because there's a lot of rules to process, and it's hard for both people and technology to manage. The service access graph is a lot simpler. Since it happens at service names, it's completely scale independent. 10 web servers, 1,000 web servers, 3 databases, 300 databases. It's just one rule, right? This service can or cannot talk to this other service. And that's really important because that enables us with Consul to replicate the whole service access graph across the entire cluster really cheaply for incredibly high-scale deployments. The second thing we have to do is establish identity and security and encryption. And we do this using mutual TLS. So TLS is sort of a perfect protocol for us to use here because TLS was designed specifically for zero trust networks, the public internet, right? That's designed for a case where the client really can't trust the destination and we need to, and it's happening over untrusted networks, and we still need to establish trust in some way. And that's exactly the mindset and philosophy we're trying to bring into private data centers as well, cloud private data centers. And we do this using TLS. TLS provides the identity and encryption. So the identity is baked directly into the certificate, and the encryption happens sort of by nature of the transport protocol of TLS. We also built APIs for getting the public certs and issuing new certs directly into Consul. So Consul does this by fronting real sort of CA providers. Consul itself has a built-in CA, so you could use Consul right away, but it's completely pluggable, so you could bring in Vault. We're working on integrations with Venafi and many more CA providers, but in front of that is a consistent API for verifying certs, signing certs, and more that every application and Consul agent can use. And the really powerful feature that we built on top of this is built-in rotation. One of the biggest challenges with TLS and mutual TLS everywhere and many certs everywhere is how do we safely rotate them? Initially getting them out is sort of a tractable problem, but then thinking about we'd like to rotate those relatively quickly becomes really challenging. And Consul handles this automatically for you. So we advertise short-lived certificates. I think the default's around 3 days. And then after 3 days, we automatically rotate, serve both, and after all the traffic sort of drains out of one, start serving exclusively the other one. And more sort of impressively, we also rotate the CAs for you. So you could rotate intermediate keys, root keys, and actually the whole CA provider. You could switch from the built-in to Vault, to Venafi, back to Vault, sort of whatever you need as your organization changes. And we handle automatically sort of cross-signing CAs, issuing those cross-sign certificates, the right routes, waiting for the traffic to drain, and flipping over, so that the whole time during the rotation process, your connectivity is preserved across the whole cluster. And we could do this across every service all the time. The last thing is the data plane. And when we talk about service mesh, it's really important to separate the concept of a control plane and the data plane. The control plane is what's defining all the rules. Who could talk to who, sort of what are the configurations of everything. And that's where Consul firmly sits. It is a control plane solution. The data plane is the thing that's actually sort of sitting in the path of data, verifying the certificates, consuming the configuration from the control plane, and reacting to that. And for Consul, it's a pluggable data plane. So we have a built-in proxy into Consul, and we just do that so deployment's easy, but it's not really meant for production high-scale usage. For that, we bring in pluggable proxies, and you could use whichever sort of proxy you want to use. Visually, what this looks like is this. You have the Consul client, which is the control plane configuring a proxy. You have an application that's using Connect that wants to talk to another application. It goes through a local sidecar proxy, which is very performant just because it's over loopback, and most operating systems optimize this heavily. It goes over the network, and then goes into the application. And these proxies are totally pluggable. So you could drop an Envoy there. And I think more importantly, you can mix and match. So one side could be the built-in proxy, the other side could be Envoy, it could be anything else. And as long as it speaks the Connect protocol, which is just mutual TLS, it's not anything sort of novel or exotic, then it all works. And this is really important for deployments across heterogeneous workloads, which is sort of the bread and butter of what HashiCorp does. If you have one server that's on Linux and you have another server that's on Windows, the best of breed proxy, the best performing proxy might be totally different, and we allow for that heterogeneity. Or if you have one side that's really not performant dependent at all and just wants to use the built-in proxy, that's totally fine too. In addition to Connect, we've made huge strides on the UI. So Consul's had a UI for many years, and we haven't updated it in over 3 years. And this year, we released a brand new UI that supported every feature of the old one and has also added new features, such as sort of the Connect intention management. And thanks to our awesome UI team, we've also been shipping features right away with support in the UI. So the same day features come out, we're also supporting them directly in the UI, which historically we've never been able to do. And in addition to shipping these features, we've also been improving the core of Consul to make the stability and scalability better, just for the core features that existed for years. So back in July, we were really excited to work with a user on seeing the largest single data center deployment of Consul ever. Their single data center deployment was 36,000 nodes. And we have larger deployments by node count across multiple data centers, but this was all in one data center, all one single gossip pool, gossip network. And it was really, really amazing to see. It didn't come for free. We had to make dozens of improvements sort of in the core of Consul. But the benefit is that these improvements benefit everybody. So everybody, as they've upgraded Consul, will see sort of lower CPU usage, less network consumption, and more stable leader election under sort of pathological conditions. And it just makes everyone's deployments better thanks to these large-scale deployments. At the same time, we have a user right now that's preparing to test Connect, which I just talked about, across 20 data centers and thousands of nodes, which is really exciting because that becomes one of the largest sort of production service mesh deployments in the world. And so what I want to talk about now is Consul 1.4, which is something that is available today in a preview version and we've been working on for a while. The first thing we've done in Consul 1.4 is integrate deeply with Envoy. Envoy is a high-performance, production-hardened proxy, and now you could use that directly with Connect as an option just as easily as the built-in proxy. We automatically configure Envoy, we'll run it for you, and more. Our Kubernetes integration also uses Envoy by default, so you don't have to do anything, and we're just running their Docker images for you. And we also expose the ability for you to pass through custom Envoy configuration. So if you want to configure layer 7 routing, observability, and more, you could do that through Consul through the pass-through Envoy configuration. We'll look at adding more of those features first class in the Consul, but this is a great way to get all those benefits without having to wait on us. And just to look at how easy this is this isn't just a demo, this is sort of like a real configuration you might see in production, is when you define a service, you would define that you want a sidecar for that service, and then to run Envoy, it's one command, Consul Connect Envoy, and then specifying which service you want a sidecar for. And what we do there, Envoy isn't the easiest thing to configure. We generate the Envoy configuration. We set up the right network addresses to point it back to the Consul agent. And then we fork an exec and start Envoy for you for whatever's on the path. So you could use multiple Envoy versions as well. And this just gets it running really, really easily. The other thing that we're bringing in Consul 1.4 is a revamped ACL system. So the ACL system in Consul hasn't really been touched since early versions. And since then, we've shipped 2 other ACL systems, policy systems, in Vault and Nomad. And we've worked with customers at very large scale and learned a lot about how to improve the ACL system and what works at that scale. We've now brought the same systems and same learnings that we've had there back down to Consul into a new ACL system in Consul. This has a number of important features. We've first separated the access token from the policy, so you could have multiple policies and assign tokens to those. You could also now restrict policies by data center. So certain policies are active only in certain data centers. We also support exact match policies. So before, everything was prefix match in Consul, which made it difficult in some scenarios to get exactly the right security that you wanted. And then finally, as a performance feature, we introduced DC local tokens. So data center local tokens are tokens that aren't replicated globally. And so generally, you could have thousands of these in a single data center without pushing sort of any replication burden onto your global deployment. And this is super important for performance. The ACL system is completely an open source. It's backwards compatible with the existing ACL system. And we've done some really neat things to upgrade you. A big part of that is the UI. So this is an example of one of those features where day one, right at launch, we support the new ACL system directly in the UI. And a really cool thing we could do with things like a UI is when you come in here with a previous ACL system, which, like I said, is backwards compatible, you're using the old one, we will guide you through a multi-step flow to upgrade those tokens for you. We'll guide you to take the ACL, turn them into policies, set up the replication for those policies, and associate them with multiple tokens while preserving the exact same access token ID so that none of your applications need to actually be rotated. They'll still keep using the same secret, but in the background, we'll be upgrading that to the new system. So check out the UI, check out the new ACL system. It all works really great. And the last thing that's really exciting that we've been working on is multi-data center Connect. So one of the major restrictions of Connect when we launched it in June was that it only worked within a single data center, 2 services within a single data center. Now, with Consul 1.4, a service in data center 1 can communicate to a service in data center 2 with an end-to-end TLS encryption across the whole thing that is authorized using our intentions. So you could say, web can't talk to DB, and if DB is in a totally different region, we'll enforce that across, and we'll ensure that it's encrypted all the way end-to-end across. To make this possible, we replicate and manage the replication of the certificate authority across the multiple data centers. And the important thing is this works with any provider. So the provider backing Consul does not need to be multi-data center aware at all. Actually, what we've found as we've investigated new CA providers is that very, very few CA and PKI solutions work across multiple data centers. And so using Consul, we sort of replicate and manage that global distribution of certificates for you. And this is pretty much magic to see. This is a feature in Consul Enterprise and is available as part of 1.4. So Consul 1.4, as I said, is available today as a preview version. You could go download it right now and see all these features right now.